Alright, so we have a graph here. It asks us 3 questions about the graph. How many turning points does this function have? How many real zeros does it have? And what appears to be the degree of this function? So my kids don't like it. You're driving, and then they notice something. They kind of stop, right? Hey, Dad, how come you're making a U-turn? I made a mistake, kids. I made a wrong turn, right? I missed the exit. So here, this is called a turning point. Everyone say turning point. It's a turning point because you're going from increasing to decreasing, right? Maybe you're kind of sad about this class, right? Your grades, maybe. And you realize, you know what? I'm going to go to college. I'm going to make something of myself, right? You have a turning point in your life, right? You start increasing and thinking positively about life, right? So that's what a turning point is. So, question number 1. How many turning points does this function have? Let's count. Ready, set, go. 1, 2. So we have 2 turning points. Next question asks, how many real zeros does it have? Zeros refers to the x-intercepts. Reals means that it touches or crosses through. Let's count. Ready, set, go. So we have 3 real zeros. Now they ask us a question. What appears to be the degree of the function? Well, I notice the end behavior. One starts down, one starts up. Well, what really easy equation does that? A linear equation. Y equals x to the first power. This degree here is odd. Starts down, ends up. That matches ours, so ours has to be an odd degree. And the answer for this problem is 3. So to review, the degree of our function is equal to the, at most, maximum number of x-intercepts. They call this fancy word the fundamental theorem. Fundamental theorem of algebra. And then the second idea we just learned from here is that the number of turning points, class, what does that stand for? Is going to be your degree minus 1. So the most amount of turning points we'll have is your degree. In this case, it is a 3. So 3 minus 1 gives us the 2.